everyone, so we're going to do another video over the weekend on our new section called Piecewise functions. So we're going to learn how to evaluate them today. In a second, we're going to do the handout that says 1.3 Piecewise function notes. Not the back side that says homework, but the front side that says notes. But before you guys get to that, we're going to, in your notebooks, write the definition of what a piecewise function and then explore it a little bit. So this is section 1.3. We're going to title it as, and it's on piecewise functions. We're going to learn how to evaluate them, graph them, write them, and apply them to real-world scenarios during this section. So the definition is a piecewise function is a function composed of multiple functions each belonging to a part of the domain. So what you have to envision is you take a bunch of different functions, any of the ones that we're going to learn about this year, but we're mostly going to stick to linear when it comes to graphing. But you take pieces of them and you group them together to create a new function that doesn't have a typical shape to it. And when I say each belongs to part of the domain, is that there's a domain of this whole function, but it's like you're taking the pieces of the individual functions and restricting those individual domains and then placing them together to get an overall domain. You'll see more of what that looks like in the next example on the actual visual, and plus when we start to graph them on Monday. That's the definition. We will come back to your notes later. We'll put one evaluating example in your notes. But first, we're going to go next to this handout right here that looks like this. We have a visual of what a piecewise function graph looks like. We have over on the left, we have a linear piece. Right here, this is a linear piece. We have a quadratic piece. And then we have another linear piece that have all been put together to create a function. You can see that as well when you look at the actual equation of this piecewise function. So this top one is linear. That was talking about the left piece. The middle one is quadratic, which is the middle piece. And the bottom one is linear again, which was the piece on the right, which created that ray. What creates these pieces is this part right here. And next to that, I would like you guys to write domain. And so that is our domain of the function overall. And individually, those are the domains of each separate piece. So for example, this top linear function, instead of having that whole line, 2x plus 1, we only want the line when the x values were less than -2, which is what you see on this left piece on the graph. It started at -2, right here. We look down. I bet you guys can't see me pointing sometimes. I'm pointing my own screen. If you look down, that piece began at -2, and then the x's are going to the left, and it keeps decreasing in terms of x values. Only focus on the x values, not y values when it comes to range. Don't think up or down, think left or right. What I want you guys to do right now is pause the video, go ahead and complete questions 1 through 5 based on what we've already learned, evaluating from a graph, that we know how to do. And then I'm going to show you how to go back and evaluate it from the equation rather than the graph. So again, pause, take a minute. I'm going to keep talking because I'm going to keep recording, but you guys pause it and evaluate those from the graph, and then unpause to see how I will evaluate it from the equation. So for number 1, make sure to hit unpause now. When we go ahead and evaluate f of -4 from the equation rather than the graph. So when you did it on the graph, you should have gone to -4, looked down until you hit a point on the graph, and looked over to the other side. So I know I drew all over this, but it appears, looking at it correctly, when I go down -4 and over, I should be getting a y value of -7. Let's see if that happens when we do the equation. So when I take -4, which is an x value, I have to sub it only into one of my pieces. Every x has only one home. You can't sub it into all of the pieces. You'll see me do a little of that when it comes to graphing. That's a little different. For evaluating, it only goes into one based on the domains, individual domains. So -4, you have to ask yourself, is -4 fall into here, here, or here? Is -4 less than -2? Is -4 between -2 and 2? Or is -4 bigger or than or greater than or equal to 2? And that answer to that is -4 is less than -2. So I'm going to sub it into the first piece. So we'll have 2 times -4 plus 1, which is -8 plus 1, which is -7. You'll see that matched up with the answer that we got on our graph. Same thing's going to work for all the other ones. So number 2, f of -1, ask yourself those same 3 questions. Does it belong less than -1, between, less than -2, between -2 and 2, or greater than 2? And -1 is going to fall into piece number 2, because -1 is between -2 and +2. So f of -1 is going to be subbed in for that x, which is being squared, to get an answer of +1. And you should have gotten that same answer when you evaluated it from your graph. I'm going to have to eliminate, tweak this out, and go ahead and work on the next question. So we have f of 3. So f of 3, same restrictions, we're looking here again, here, and here. 3 is going to be greater than or equal to 2, so I'm going to sub it into the third piece. So f of 3, I had a negative coefficient on that third piece. So now I'm going to sub in my 3 plus 6, and -3 plus 6 is +3. You'll notice that as I input, I use piece number 1 first, then piece number 2, then piece number 3. It's not always going to be that way. I could have started with piece number 3 or piece number 2. I could have given you all numbers that fell into piece number 3, like I could have given you up to 4, 5, 6, 7, 8, 9, and never use the other pieces. So just because I'm going in order here doesn't mean you're always going to go in order and sub it in 1, 2, 3. The last one was probably the trickiest one for you guys to find on the graph, because if you look on your x-axis, it doesn't go all the way out to 10. So you might have tried extending your line and maybe estimating to see where it would have reached at an x value of 10, 5, 6, 7, 8, 9, 10, and look down. I don't know, I'm getting like maybe a -3 here if I estimated from the graph. But if I use my equation, I'm going to be able to get more of an exact answer rather than an estimate. I can already tell looking at my equation that I was close, but it wasn't exactly correct. So when I look at 10 and go back to my 3 restrictions up here, 10 is again greater than or equal to 2. So I'm going to sub it into the third piece. So I will have f of 10 equals negative, and then input a 10 plus 6, and that'll equal -4, which is slightly different than what I estimated from the graph that I extended. So definitely more accurate to do it this way. Last thing I want to point out for one example in our notebook is the whole idea of your equal to when you're looking up here in your domain. Let me just clear this out so it's a little less confusing to look at. Okay. If I asked you to do f of 2, you would have to decide where that belongs, because I see a 2 here and I see a 2 here, but I cannot sub it into both pieces. Again, it only has one home that it goes into. So you have to ask yourself which one has your equal to. And whatever one has your equal to, that's the one you sub it in. So because this bottom domain restriction has your equal to, f of 2 would belong to piece number 3, not piece number 2. And I believe on the bottom here, I'm not going to scroll down, but you guys can go ahead and write it on the bottom where I asked for domain and range. That's just review, although this graph does have some jumps in it. So domain, if we look on the left side down here, it's going to keep going to the left, so -infinity. And as I come up I see a hole here at -2, but if I look above it, there's a point at -2. That means I don't have to stop and exclude -2. I can just keep on going because -2 is part of my graph, and I just keep on going until positive infinity. So this particular domain has no restriction. I would like to point out though, let's just pretend for a second that when this first piece stopped at -2, this next piece didn't start until -1. So we're going to pretend that that wasn't there at all. If that happens, and these 2 points are not directly above one another, you would have to use a union. So you go negative infinity to -2, exclude it with a parenthesis, union, we don't start again until -1 right here, and there's a point there, so that would be a bracket at -1, and then all the way to infinity. So you're really asking yourself again, is it part of my graph? If it is, include it. If not, I have to stop, exclude, and do some unions and see what is part of my graph. The range on this, on both ends, the graph is going to continue downward, so it's negative infinity. On the left end, we stop at a y value of -3 and don't start again until a y value of 0 up on the origin. However, this end right here, as I go up this way, I'm hitting every single y value. So even though this section, there were no y values on this part of the graph, if I look over there, there are y values on the right side. So therefore, I can go from negative infinity all the way up until 4 was the top of my graph. And there was a point on 4, so there is a bracket there. So now let's switch over to the notes part. We're going to do one evaluating example in your notebook, and then that's it. And you're going to go ahead and try those homework problems. So you write the evaluate here. That's our goal. And there is one real world problem on the homework that still involves evaluating that I want you to give a try, even though I'm not necessarily going to do an evaluate in this real world in this video. You just have to be able to interpret what your x and your y values are representing in that scenario, and then do the same as if you would if it wasn't a real world. So what's going to make this problem a little bit more challenging compared to that graph that you guys just looked at? Make this big enough to have 4 rows in it. I'm going to give you a function with 4 pieces, and I'm doing that because I want to kind of give you an idea of everything at once. Okay, so I'm throwing a whole bunch of different type of functions at you in this piecewise. We will not graph anything like this. When it comes to graphing, we're going to stick to linear and constant, and that's because we haven't learned how to graph anything except linear and constant. However, when it comes to evaluating, I can throw any type of function at you and expect you to know how to evaluate that. So the top one's a constant piece, linear piece, quadratic piece, and then a square root piece. This would look like a crazy looking graph. So the first piece is going to have, sometimes you'll see the word if. Sometimes it'll be there, sometimes it won't. The first piece, the y values will equal -7 if the x values are less than -10. The y values will be represented by 2/3 x minus 8 if the x values are between -10, including -10, and -2, but not including the -2. The y values will represent the third function if we are between -2, including it, and 3, excluding it. And the y values will represent the square root function if the x values are greater than or equal to 3. No numbers were skipped here, so technically this will have a domain of negative infinity to positive infinity because when the first one stopped at 10, the second one started. When the second one stopped at -2, the third one started. And when the third one stopped at 3, the fourth one started and kept going. This would not have a domain restriction. However, individually, the individual functions have been restricted to create this piecewise function where all the pieces can put together to create a new funky looking function. So we're going to evaluate it a few times here. So we're going to start off with f of 4. So looking at that, you're going to ask yourself, where does 4 belong? Looking at, again, these restrictions right here. At any point, please pause and try these on your own, and then you can go ahead and check to see if you get the answer correct. So I'm going to go ahead and sub in 4 to the third piece because 4 is greater than or equal to 3. So I will end up with the square root of 2 times 4 plus 17. That's going to give me the square root of 8 plus 17, which is the square root of 25. And I get an answer of 5. Get a whole number there. You're not always going to get a whole number. You might have to square root it and get a decimal, or leave it in simplest radical notation. But there, we got a whole number. And that means when you input 4 into the piecewise function, your output will be 5. So there's a point somewhere at 4 comma 5 on that square root function piece. Next one we're going to do is f of negative 2. Again, pause, try it on your own, and then check. Negative 2 is one of the overlap points. It belongs to piece number 2 and piece number 3. So I'm going to go with the one that has the or equal to sign. You'll see piece number 3 has the or equal to when it comes to the negative 2. X is greater than or equal to negative 2. So I will sub it into piece 2. I will have 3 times negative 2 squared minus 4 times negative 2 plus 1. This becomes 3 times 4 plus 8. There are 2 negatives there, plus 1. 12 plus 8 plus 1 is 21. Here's our second answer. We have 3 more to go through that you're going to try, and then we're done for the day, and you go do your homework. Next one we're going to do is f of negative 1. And so f of negative 1. Figure out where that belongs. So negative 1 also is between negative 2 and 3. Using that same quadratic function again. It belongs to that same piece. Go through order of operations. So you paused and did this yourself already and are checking. 8 plus 4 plus 1 is 8. 2 more. F of negative 6. Pause and figure out where that goes. Negative 6 is between negative 10 and negative 2. So I will use that second linear piece there, the 2/3 x minus 8. So I will have 2/3 times negative 6 minus 8. I guess it was minus 8, not plus 8. Now I'm going to go ahead and multiply the fraction with the negative 6 and then subtract 8. You can put this over 1 to help you with your multiplying there. You're going to get positive 12 over 3, take away 8, which is 4 minus 8, which is negative 4. When you multiply these two, you're not always going to get a whole number. So in this case we did. If not, you'd have to do common denominators when subtracting it from the b term, in this case the negative 8. So sometimes you'll get a whole number, but sometimes you'll have to use your fraction skills. And the last one, we're going to go ahead and do f of negative 12. I look back up at my function. Negative 12 is less than negative 10, so I'm using my first piece. Notice I did work my way up. That's just a coincidence. We don't always start bottom to top or top to bottom. I could have jumped all around in any particular order. So negative 12 is being subbed to the first piece, but there's no x value there. That's a constant function. Y equals negative 7. So if you think about what a constant function looks like, normally they continue left and right. It's a horizontal line where the y value is always negative 7. So for all x values that are less than negative 10, the y values will always be negative 7, nothing else. So there's no work to do there. So here, when x was negative 12, the y had to be negative 7. Input, output, there's your point on that constant piece. So that's it for the video today. Go ahead and try the homework now on this skill. And tomorrow when I see you guys in class, or maybe in a couple days from now, depending on when you watch this, we're going to go ahead and learn how to graph these. So I'll give you the functions equation, and I'm going to teach you different strategies on how to make the graph of that function. See you guys soon. Have a great rest of your day.